Good morning. In our previous session, we have discussed about water reference electrodes, construction and working of calomel electrode, and we have seen types of reference electrodes too. Primary reference electrode and secondary reference electrode too. The construction and working of calomel electrode applications also. So today we are going to see ion selective electrodes. In second reference electrodes, we have different types of electrodes: metal ion electrodes, metal salt ion electrodes, ion selective electrodes, etc. So one among them are ion selective electrodes. Ion selective electrodes plays an important role in measuring the pH and has a various application. Let us see what are these ion selective electrodes. Ion selective electrode is also a type of reference electrode which responds to concentration of only specific type of ions when dipped in a solution containing mixture of ions. Let us consider we have a ion selective electrode. This is ion selective electrode. We are going to take a tumbler or a beaker which contains n number of ions, maybe Na plus, Cl minus, Li plus, H plus, etc. So this electrode will determine or corresponds to the concentration of only Na plus. Now dip this electrode in this solution, the potential of this electrode is directly proportional to the concentration of Na plus itself. If the concentration of Na plus is high, the electropotential will be high. If the concentration of Na plus will be low, then the electropotential will be low. So the electrode potential directly corresponds to the concentration of the ions which is dipped in. So for lithium we have different ions, for H plus we have different ions, for sodium we have different ions, for Cl minus we have different ions. So in earlier days, if you want to test the water sample, the hardness of water, we used to take the hard water or borehole water or well water and send the water sample to the laboratories. But nowadays, you might have seen the person comes, maybe Eureka Forbes or anyone who are going to install the RO water generator in your house. He'll come, he'll ask a glass of water, he'll remove the pen from his pocket, he'll insert in the tumbler of water, and immediately he'll tell the TDS, right? So total hardness present in that, right? So what is that? So how is it possible? It is only possible because of here ion selective electrode. We have a different electrode flow of fluoride, we have different electrode flow of chloride. So fluoride concentration high, then it causes fluorosis, dentofluorosis, right? So whether the water is potable or not, within fraction of minute we can decide. That is the major advantage of this ion selective electrode. So if you want to find out fluoride concentration, once again you have to send the fluoride water sample to the laboratory, test, once again you get it, but it may take months together, but now it is instantaneous, spontaneous, instantly on the spot we can get it done. So different types of membranes available in the ion selective electrodes are solid state membrane, liquid membrane, heterogeneous membrane, and glass membrane. So let us see the construction and working. Today we are going to discuss about glass electrode. So this glass electrode corresponds to the concentration of H plus ions. As discussed, we have different electrode flow of fluoride, we have different electrode flow of sodium, we have different electrode for lithium. So similarly, with this glass electrode corresponds to the concentration of hydrogen ion, H plus ion. So this glass electrode is an example for ion selective electrode. So this glass electrode consists of a bulb with high conductivity and low melting point. So this bulb, whatever bulb you are seeing here, it contains a solution of known pH and concentration. So normally used solution inside the bulb is 0.1 molar HCl. It also contains an internal reference electrode. So normally we are going to use silver chloride as the internal reference electrode. This entire setup will be dipped in a solution containing H plus ions, of unknown concentration. So the glass membrane, so because of difference in concentration, the glass membrane undergoes the ion exchange reaction across the membrane. The H plus ions present inside the bulb will get exchanged with the H plus ions present outside the bulb because of the difference in concentration. So this reaction occurs until the concentrations of H plus ion inside the bulb and outside the bulb are equal. So the above diagrammatic representation of glass electrode can be represented by like this: Ag/AgCl, that is internal reference electrode, which is dipped in 0.1 molar HCl and glass membrane. So as I told, there will be a ion exchange reaction across the bulb, right? So why it occurs? It occurs because of difference in concentration of H plus ions inside the bulb and outside the bulb. So this occurs until the concentration of H plus ions inside the bulb and outside the bulb are equal. So this ion exchange reaction occurs as follows: H plus plus Na plus Gl minus gives Na plus H plus Gl minus. The H plus present inside the bulb will get exchanged with the Na plus in the glass. You know that glass is nothing but sodium silicate. It will get exchanged with the Na plus with the Na plus of the glass, and that H plus will come out, right, will come out and liberate Na plus. Once again, this H plus, which is present outside, it will get attached to the glass, it will go. It is a reversible reaction. So this reaction occurs until H plus ions inside the bulb and outside the bulb are equal. So due to this, what will happen? Across the boundary, a potential will be developed. Due to this ion exchange reaction across the bulb, a potential will be developed, and that potential is known as boundary potential, and it is denoted by EB. It is denoted by EB. So this boundary potential can be obtained until the concentrations of H plus are different inside the bulb and outside the bulb. Once the concentration of the H plus ions inside the bulb and outside the bulb are equal, EB equals 0. Okay, but in practical, even when the concentrations of H plus ions inside the bulb and outside the bulb are equal, even then some potential arises across the boundary, and that potential is called as asymmetric potential. What is asymmetric potential? Even when concentration of H plus ions inside the bulb and outside the bulb are equal, some potential arises across the boundary, and that potential is called as asymmetric potential. So earlier you used to have the derivation of electropotential of glass electrode, but now it is not there. So the electropotential of glass electrode is determined or is derived from Nernst equation and is given by Eg equals Eg naught minus 0.0591 pH, where Eg naught is constant. So Eg naught is equal to summation of internal reference electrode, asymmetric potential, and a constant K. Now let us see the advantages of glass electrode. So it is a rapid response. It is unaffected by oxidizing agent and reducing agents or salts or moderate concentrations. That is in moderate concentrations only. But so the disadvantage of fragility, imperfections in the bulb may cause error. Regeneration required over a period of time to avoid errors. Disadvantages. It can be used in solution containing oxidizing agent which will oxidize, or reducing substance which will reduce, especially in presence of platinum black. It cannot be used in reactions involving volatile constituents, example carbon dioxide, as it will be bubbled out by hydrogen gas. It cannot be used in presence of catalytic poisons which will affect platinum black, which catalyzes the electrode reaction. It needs repulsion with platinum black, and it is not easy to keep hydrogen gas at 1 atmosphere pressure during all measurements. So this is the major task. So it is very difficult to keep hydrogen gas at 1 atmospheric pressure. So let us see the applications or uses of glass electrode. It is used in pH measurements. It is used in analysis of food, cosmetics, environmental regulation, soil acidity. So these are the uses of the glass electrode. So it is fast responding and functions well in psychological systems, but especially in biological systems. So let's discuss the applications of this determination of pH using glass electrode in our next class. Thank you.